and welcome to the Agricultural Engineering Podcast. This podcast covers all aspects of agricultural engineering. It is produced by the South African Institute of Agricultural Engineers. The series of episodes that will be brought to you has been funded by the Royal Academy of Engineering. We encourage you to tune in and explore the exciting world of agricultural engineering with us. My name is Kutazo Nzue, and I'm your host for today's episode. In this episode, we will be discussing the role that agricultural engineers play in ensuring energy and energy efficiency for agricultural machinery and equipment. Joining us today is an agricultural engineer with 28 years of experience in the field. He is an academic and head of Department of the Engineering Science at the University of Free State, a board member of organizations including the South African Institute of Agricultural Engineers and the South African Energy Efficiency Confederation. He is the owner of Kwetsa Communication and trainer for courses of the Association of Energy Engineers. With us today is Mr. Louis Lagrange. Welcome to the Agricultural Engineering Podcast.
Thank you very much. I'm glad to be here to share a couple of things with you today.
So let's dive right into this conversation. Could you tell us about your path towards becoming an agricultural engineer, focusing on what led you to specialize in the area of energy?
I actually didn't know that agriculture engineering existed. So I come from a farming background, and being the fourth generation, the expectation is Louis is going to be number 4 farmer on the family farms. That was my destiny. Until I went to the army. During my national service, I was grouped in a bungalow with a lot of engineers, people that's already studied engineering. And there I thought to myself, it is very interesting. The engineering approach to solving problems is something that I've never seen before. And we were in the army doing specialized training on sammels and rattles, that's vehicles and engines. And I was impressed with the thorough understanding that the engineers have got of engines, and the thorough understanding the engineers have got of optimization systems. So I combined agriculture with engineering. And although the first 2 years was quite hard, when I got to my third year and we combined the agriculture and the engineering, I was in heaven, and I'm still in heaven. The second part of your question, what focused me to specialize? My first job was to spend 12 years in Eskom selling electricity. I say that very kindly, selling electricity, because Eskom had so much electricity, they didn't know what to do with it. So we formed a group called AgriLec, that stands for agriculture and electricity. And that group had 7 engineers and 80 people in the field. And our job was to sell electricity because there was too much. There I realized that electricity was not a form of energy. The way that I understood it at university, it is actually only a transporter of energy. So electricity transports energy, typically from the energy embedded in the coal to the energy that you use to turn the electric motor, to turn the pump. So my interest was then, just about everything in life is about the conversion of energy. And once I've realized it was about the conversion of energy, I was now hooked on energy as well.
What comes as a shock to me, and I'm sure to the South African listeners as well, is that this country once had an abundance of electricity.
Yeah. Can I just add to that not only did we have a lot of energy, we were, I think, the third cheapest in the world. And in 2001, Eskom won an international award of the best electric utility in the world. In the entire world. And I was in the group of Eskom that at that stage predicted that we're going to run out of power. And our answer at that stage was build more power stations. We're not going to have enough power because the economy is growing, build more power stations. And a little bit later today in the interview, I will tell you how I've changed my mind. We do not need more power stations in South Africa, but that will come later.
What I find intriguing, Louis, about what you just said is that this country that was once the best and cheapest electricity producer is now one of the countries with the highest electricity tariffs and the most unreliable electricity. Enough about that. Let's not divert from our conversation and your work. So, as the head of Department of Engineering Sciences at the University of Free State, can you provide our listeners with some information on what the newly formed Agricultural and Biosystems Engineering degree program that the UFS is launching in 2025 will look like?
Good. So I'm going to answer that in the light of the fact that we're starting a new department of Agricultural and Biosystems Engineering at the University of the Free State from 2025. Just a little bit of a background. We have got the go-ahead and the approval from the Department of Higher Education and Training, from the Institute of Agricultural Engineers, SAIAE. We have the approval from the Engineering Council of South Africa, EXA. We have obtained the approval from the Council of Higher Education, and we are still awaiting one little thing, and that is the ID number of the program from the South African Qualifications Authority, SAQA. Once we've got that ID number, we can go into fully fledged marketing. But I think it's important that people are aware what is happening and that we're waiting for that number. The agricultural engineer is what I call a specialist generalist. Wow, a specialist generalist. So the agricultural engineer must be aware of a wide variety of things that happens in the farming enterprise, but he must be she must be specialized enough in order to address things like pumps and irrigation systems. So if we look at this, the University of the Free State, we have some specialist generalist areas. Core engineering, we have a whole area that looks at the new smart farm systems and IT. We have a section that looks at buildings and storage. We have a system that's agricultural structures. We have an area that looks at food processing, specifically value adding. We have one section that looks at irrigation and water. That's a hydraulic section. We have one that looks at energy and energy conversion, whether it's renewable or through tractors and combine harvesters and things like that. And then we've got another specialist generalist area that looks at environmental systems. So what we've done here is we have combined the agriculture, the engineering part, the hardcore engineering part with the living world. And that's why we call it agricultural and biosystems engineering. Just to add to this, which is something which is unique, South Africa has never seen this before, the student going through this will be able to choose 3 areas of a little bit more specialization. Area number 1 will be if they're interested in animals. We're going to do cattle, we're going to do ruminants, we're going to do sheep, we're going to do cattle, pigs and chickens. And or poultry actually. Then they can either choose that one or they can go into summer and winter crops and oilseed crops. That's open land farming. Or they can go into horticulture. And that is farming under protection as well as greenhouses. So our generalist specialist will be able to specialize in one of the 3 streams in order to provide not only the market with a specific need, but also to enhance the personal passion of the student. Because if you are in an area and you're passionate about animals, then you're going to bloom, you're going to do well. So that's basically what we have. I want to just conclude by saying the agricultural engineer is a very, very unique engineer, because the agricultural engineer takes the different parts and synthesize the different parts of an agricultural process. From when the sun shines, you plow the ground or you prepare the ground, you plant the seed, you irrigate the seed, eventually you grow it and you reap it, and eventually it becomes food on your table. The agricultural engineer is the only one that in the training goes through that synthesization process. Secondly, the agriculture engineer is the only one that's able to take that whole system approach and then apply it to living things. Like what happens if you've got a banana? How do you store the banana? How do you make it ripe? What happens with that? So the agriculture engineer, and yes, I'm biased because I'm one. I'm not objective. The agriculture engineer is a unique and a fantastic synthesizing engineer. We get taught thermodynamics in our studies, and we get taught machine design. But after that, and that's why when you've studied, you're not a professional engineer, you must still acquire the expertise. You must do it. You must work in the field. You must have continuous professional development. So the mistake that people make is that they think that an BSc degree is enough, but the application is something different. Now, if we look at energy, one of the biggest challenges we have today, people talk about, oh, we don't have electrical energy from Eskom, so we're going to go off grid and we want to go renewable energy. It is the wrong approach. I'm not even going to sugarcoat it. It's the wrong approach. South Africa is taking the complete wrong approach. You should first ask the question, should this pump be on at all? Now, when you talk about energy, you have useful energy, and then you have energy that's non-useful. Let's call it waste. You have wasted energy, but you've paid for it. Remember, you've paid for everything, but you waste it. So you first ask the question, how can I avoid the waste? If you can't avoid all the waste because of some thermodynamic laws, how do I minimize it? And then how do I recapture it? And only when you've done that can you go to renewable energy. I want to give you an example. Recently, through training with the CSIR on eco-industrial parks, we took an example, and the example needed a 201 kilowatt hours per day of electrical energy at a maximum demand of approximately 16 kilowatts. After we've gone through those three questions, why is it on? Can I do something about it? We brought the 201 down to 90 kilowatt hours. So we've halved the energy use. We brought the peak from about 16, 17 kilowatts down to 9 kilowatts, which meant that your price of your system was 40% less. Now it becomes an economic, sustainable thing. So to summarize, anything that moves and anything that heats in life, and there are a lot of things that move on a farm, there's a lot of things that you heat on the farm. Anything is the conversion of energy. But I'm stating here that because we have a very academic physics approach training, we don't really understand how to apply it in the field. And I've gone through that process. I was thinking, Louis, you've got your master's degree in engineering. You can do a couple of things. Man, I had a piece of paper, but I didn't have the practice.
I'm happy that you clarified on how agricultural engineers acquire the expertise to specialize or work in energy or in the energy sector in this case. I have a question, but we'll come back to it later on. So taking into account the energy-related issues in our country, that is South Africa, what insights can you provide about the perspectives of agricultural engineers who specialize in energy solutions or coming up with energy solutions?
I think let's contextualize it. Agriculture, and I'm now talking only about electrical energy. Agriculture is not more than 3% of all the electricity sales of Eskom in the entire South Africa. We are not a significant part of Eskom sales. However, in agriculture, Eskom has invested more than 3 billion rands in the year 2020 in agriculture alone to build power lines. And the power lines were not being used on the rural areas. So taking on from everything that moves or heats, that uses energy. So if we say we buy energy today, electrical energy from Eskom, and we pay R2.50 a kilowatt hour. It's a general statement for a combined cost, R2.50. If you have to generate that electricity through your diesel generator. So what do we say? Oh, I want to go away from Eskom. I want a diesel generator. Do we know that a kilowatt hour coming out of a diesel genset starts at 10 Rand a kilowatt hour, goes up to 14 Rand a kilowatt hour? That is for the same quantity of energy. So the question is, it's a no-brainer. Do you want to pay 2 Rand 50 for energy, or do you want to pay 10 Rand or for 14 Rand? Of course, you need to take into account risk. And if you do not have electrical energy, you need to generate it by yourself. But do we know what is the real cost? And the answer is no. I have not had a single agriculture engineer or engineer that could ever tell me how much more it costs with diesel gens, which is 4 to 7 times more. So if we look at that, our big thing, the insight that I can tell agriculture engineers that we need to do, we need to understand the flow of energy conversion. 30% of the energy that goes into the engine of your car comes out, 70% is lost, is waste heat. But can you recapture the waste heat? Of the 100% of energy that you put into your car's fuel tank, you are very lucky to get 14% out, turning the tractor wheels forward. So that conversion of energy, if agriculture engineers wants to do better, look at the flow diagram, look at the conversion, and at each of the conversion steps, identify the waste. That waste I call muda. You have muda, mudi, and muri. So muda is a Japanese term that we use in the optimization of value chains. Muda says, I buy something and I throw it away. One example, I buy 2 liters of soft drink. The 2 liters of soft drink, I take 1 liter goes into my stomach, 1 liter is on the ground. Now, if you look at energy, you buy the 2 liters, and that's not 1 liter in your stomach, 140 milliliters to 280 milliliters in your stomach. The rest you waste. So our awareness of how much you waste is important. To conclude the story, if we know how much we waste, we can then start to waste less. If we waste less, we don't need another power station. We don't need it. At the moment, South Africa has got a maximum demand of 36 gigawatts in winter. We have 39.8 gigawatts of coal-fired power stations without taking anything else into account. We don't need to build more power stations. We need to stop wasting. And if you stop wasting, it means the following. Previously, when I was in Eskom 25 years ago, we said, build a new power station. Get more kilowatts out. Now we say, no. Don't get more kilowatts out. Use the kilowatts that you have more wisely, which means you're going to make more profit. We don't have to build more power stations. And with more profit, you can grow your business, you can grow the economy. So we actually, listen carefully, we have enough power and we have enough electrical power in South Africa. We do not need additional power stations, just stop the waste. Now, from this on, I can have a myriad of people that can contact me, but I'm standing with that point. I'm stirring the pot. I'm stirring the pot properly.
Thank you for highlighting on that. I think this is the second time you are mentioning it, right? Yeah. And you've also talked about the need for agricultural engineers working with machinery or in the field of mechanization to prevent or make use of the wasted energy. So according to your knowledge, what is being done? Are there any initiatives that you are aware of?
Yeah. Basically, before we get to initiatives, the agricultural engineers, or let's call it the engineers working in agriculture, because there's a wide range of other engineers doing splendid jobs. The engineers working in agriculture, we can actually say all engineers, but let's focus on agriculture. The engineers need to upskill themselves how to do energy calculations. The basic thermodynamics that we have, that is true, but we did not get the knowledge how to apply it. So they really need to upskill themselves. And we're going to be a little bit later, I'm going to give you an indication of some of the courses that are available. There are several upskilling courses, not only available, but necessary. Within the courses that are necessary, there is another thing that's happening, and that is the circular economy. The circular economy circular economy is not about minimizing waste. It's not about taking waste and reusing it and recycling it. The circular economy says you need to design circular. And we have a project that is running on the circular economy. We are starting for the agricultural engineers, that project, in October this year. At the SAIAE Symposium, we will also have an outside speaker where we have 3 webinars on circular economy. We're going to repeat the 3 webinars, and then we have training, 2 3-day trainings specifically to train people to think circular economy design. So those are some of the things that is on the table from the University of the Free State at the moment.
Thank you for clarifying on that, Louis. I hope that we can record one of these webinars to share with our global audience here on the podcast. Now, you mentioned that a BSc, for instance, in agricultural engineering alone is not enough to specialize in the energy field. So I know that your company, Kwetsa Communication, offers training such as the Energy Manager Certificate, which is an internationally recognized energy course. Why are these courses important for engineers who want to specialize in energy?
Yes. The first course already exists. It's called FEMIA, Fundamentals of Energy Management in Agriculture. And SAIAE is running those courses. We didn't have enough people last time. But FEMIA basically tells you some of the basic principles. But I'm going to highlight there are only 2 things that you can do to do energy management. Only 2. You have only 2 tools. The one is the kilowatts. And the other one, and let's make that the vertical axis, because engineers like to think in diagrams, and let's make the horizontal axis the time. So in order to do energy management, you can either reduce the time, how long the switched on, or you can reduce the amount of energy that it uses. So I can take a light that is a downlighter of 50 watts. I can replace it with an LED light of 4.5 watts. I save more than 90% of the energy. Now, on those 2 things, number 1, the fundamentals course trains you can change the kilowatts with technology. Secondly, you can change the hours with either the human beings, but they are notoriously unreliable. After 18 days, they forget their training. That's only 18 days, unless you embed it. And you can change it by only 2 tools, is basically change the technology and change the control systems. That's the FEM course. On top of them, there are several other courses. You can do courses from the Association of Energy Engineers that are all short courses. And we have the license in South Africa to train those short courses through the Institute of Energy Professionals Africa. And the highest one regarded short course in the world is called Certified Energy Manager. The Certified Energy Manager tells you or teaches you how to calculate the waste. How big is the meter? That's the entire course, calculate the waste. Then we have Certified Energy Auditor, how to audit where you are and predict into the future. They have Certified Measurement and Verification, how to prove, and if you can prove your savings to South African Revenue Services, you get a rebate on your tax of 95 cents rebate for every 1 kilowatt hour that you save. That's a Certified Measurement and Verification professional course. There's a Certified Lighting Efficiency professional course. There's a Water Efficiency professional course. There's a Business Efficiency. There's a Carbon Assessor, and there's a Renewable course. So those are a couple of the courses, but that can be augmented by the CSIR, the National Cleaner Production Center. They have courses from UNIDO, expert fan courses, expert pump courses. All of the courses that I have recalled now is about application. But the unique thing about the Association of Energy Engineer courses, like the CEM, the Certified Energy Manager, they teach you how to calculate the waste. But the second part is actually crucial, because without that, you are not going to have a success. And that is how to do the financial calculation. We have at university, we have been taught on the financial calculation of the engineering side. But that's not how the chief financial officer is going to approve your project. The chief financial officer is going to approve your project on financial terminology for the chief financial officer, like net present value, internal rate of return. So those things are not well embedded in the current structures of our training, and all of these courses, there's not a single one of them that doesn't teach you how to do that. So there are quite a number of courses available if you search for it. And many of the courses, like the UNIDO courses on the expert level on fans and pumps, it's an expert level where I help develop them on renewable energy and cleaner production. There's an expert level on energy management systems. Those are the things. There's no time in our training. And if the agricultural engineers or engineers in general and in agriculture doesn't develop themselves on those courses, they're going to be left behind. And the industry is not going to wait for them. So those are some big stirrings that I'm bringing into this conversation today, eh?
I'm sure people will be looking for those pots that you are stirring today, Louis. What I will try to do is to share some of the websites of the courses that you've just mentioned in the description box for our listeners to maybe get access to those. So let's get back to the conversation. You have given a sort of a background on energy, what it is, and how best it can be preserved. So what is energy efficiency, and how do engineers in general, including agricultural engineers, take it into consideration in their respective work, for example, in engineering design?
Let's take the two tools that I've shared. The one is the kilowatts, the other one is the hours. Now, when do you save the most? You save the most when you switch off, when the hours is 0. We ask the questions, does this piece of equipment have to be switched on 24/7? So if we take it to energy efficiency in agriculture engineers, we can ask the following questions. The tractors, are you measuring if the tractor is using its optimal gear? If the weights on the tractor are correct. If you've got 50 kilograms too much on the nose of the tractor, 1% more energy inefficiency or 1% more fuel use. Do the farmers change the tractor weights between different soils and on different between different lands? And I'm telling you a resounding no, not yet. Do they apply smart farming principles? I call it agricultural 5.0. Today, the physics and the calculations of the physics are exactly the same as 30 years ago. The physical laws has not changed. But what has changed, we have now control systems. We have variable speed drives. So if we go to irrigation, only irrigate when it's necessary. We have control systems where we measure the field and moisture in the field, when it's required, how much is required. And then with irrigation systems, let me give you an example. If you have a variable speed drive that you put onto a pump, the variable speed drive is going to change the speed of the electric motor, which means it's going to change the speed of the delivery. An example, if you reduce the speed of the electric motor by 10%, you reduce the volume that you're pumping by 10%. Okay, if it's a centrifugal pump, or approximately 10%. Then you reduce the amount of kilowatts that you need by 27%. 10% less speed, 10% less volume, 27% savings on your kilowatts. Now, this is what they teach us at university, 27%. But what's the reality? The reality is that the variable speed uses between 4 and 7% energy to do its job. The reality is, if you change the pump from its optimum best performance point, the efficiency of the pump will go down. But let's take that into account and say, in practice, you can save between 20 and 21% of your energy use by reducing it by 10%. Now you can start to do the calculation, because it's the cube law. If you reduce it by 20%, you can save up to 50% of your energy and your electricity bill. Those are the type of things that, although we understand the formulas and we've passed our degree, the application of this on your bill at the end of the month is not well understood. So basically, we use technology, new technology, to bring the kilowatts down. But secondly, we use monitoring technology. In other words, to tell us on an immediate basis, real life basis, what is happening. And with the new tractors, it optimizes which gear you're using. It optimizes one of the 1,000 gears if you have a hydraulic system. Another very simplistic thing is, let's not drive around on the farm checking, are the pumps working? Do I need to restart the pump? Let's not drive down on the farm and say, are the water troughs for the animals full? You have monitoring systems. You have real-time systems that can tell you what's happening up. And all of that not only uses your time, you use your bakkie with the fuel, you pay for all of that. And in the meantime, while you're driving to do all of that, you could have sat at home controlling the systems and adjusting it from your seat. So it's not only technology, it is the wealth of control systems that we have. And that is what makes this exciting. The agriculture engineers do not have to develop it. It has been developed by people with thick glasses and white coats in laboratories anywhere in the world. We just have to take it and apply it. But I'm very careful what I say. We don't know about it. You can't apply it if you don't know about it. And you will only know about it when you train yourself, when you continuously develop yourself by coming to training courses. And we don't have to write the training courses. Somebody else has done the training courses. You just go and sit and get all of that information. And all of that information is available on internet, but it's not in your head. So if you go to training, it's internet information that somebody has taken and said, I synthesize it into a understandable whole. And within 5 days, we cover 2 years of thermodynamics in the CM course. 5 days, say this is how you really apply it. So that's the opportunity for agricultural engineers.
You couldn't have said it any better, Louis. Agricultural 5.0, which includes continuous monitoring technologies, is the future in the field of agricultural engineering. And I also agree that the only way to stay up to date with the evolving technology trends is through continuous education.
Yep.
So you mentioned or you've highlighted on some new technologies that are being used, for instance, in irrigation. Are you aware of any technologies that are being used in food and fiber, and whether they are accessible in South Africa?
That's an excellent question. And the answer is yes, it's available. And the answer is further. Yes, it's not only available for big farmers, for mega farmers. It's available for the small scale farmer that has got very small area, but the technology is in most cases freely available. So if we look at what happens and we look at energy efficiency, in some countries in Africa, up to 72% of the produce that they produce goes to waste. In other words, it's eaten up by insects, rodents, or it just goes bad before it reaches the stomach of the consumer. So if we want to increase our energy efficiency, we already produce everything and then we throw it away. 72% in instances. Let's say in South Africa, and I don't know what is the figure, but let's say in South Africa, 15% of everything that you produce gets rotten before it reaches the end user. If you now want to have energy efficiency, you have already invested to produce the crop. Rather now invest in two things: storage, mainly storage, and invest in processing. And for both of them, you have to invest to make sure the product stays healthy for the final consumer. But now it's going to cost you less energy if you do energy efficiency, so you can make it cheaper. You can make it more affordable. That means more affordable, you can move it to the market and somebody's going to buy it. So if something moves, if something is heated, anything has to do with energy. And do we take that into account in our calculations? No, not yet. Not yet. After the courses, you start to do that.
So let's quickly talk about energy projects. You've mentioned the CSI projects that you are involved in. Please provide more information on it and maybe a few more examples of successful energy projects that you've seen agricultural engineers play a role, or any that you've worked in yourself.
Yes, we're working together with quite a number of companies, but a couple of concepts, and that is, do we really understand the amount of energy that we put into flowing water? So one of the things is to say we put variable speed drives in, but then you need to measure. Because if you produce pressure through an irrigation system to the very last nozzle, and that pressure is too high, what do you do with the pressure? You demolish it. If you put water through a pump, and at the outlet side of the pump, you have a valve, and that valve is half closed. You can think about it the following. The pump is a pressure-producing device. You pay for pressure. The result of the pressure is moving water. So you pay for all the pressure. Now, just after the pump, you have a demolishing device. You demolish with a half-closed valve that you've just created. That is energy-wise really not, I would say it softly, not a good decision to demolish what you've just paid for. That's why variable speed drives are important. But do you understand that you create the power? Then, through the system curve, how do you demolish it on different parts of the system curve? You don't know until you measure. You don't know whether a valve somewhere in the system is stuck in the closed or half-closed position. So in my next life, all valves will be see-through, that I can see what's happening in the inside. That is one of the things. If I come back to the earth, reincarnated, all valves will be see-through. So I can see how much we are demolishing. So we're getting back to how much you're wasting. We have a lot of engineers, wider than agriculture engineers. There are many more solar systems and photovoltaic systems being erected in South Africa by farmers than we are aware of. Now, one of the things that can happen is there is small-scale embedded generation. So Eskom allows the farmer now to pump the energy back into the system. So excess energy can now go back to Eskom. However, there's one small little problem there, and that is if the line doesn't have space for the additional electrons, you can't do it. So unfortunately, electrons still needs to move through lines. We have people with water pumping storages. We have people that has used time of use. We have actually, we are busy at the moment with a project, and I can't let out too much, where we would like to take farmers, a group of 10 farmers that's on one line, and say, farmer number Louis, he is specializing in avocados. Farmer number 2 is specializing in something else. And then when we have load shedding, we actually call it now load sharing. And say, Louis, on your farm, you can now take 4 hours of load shedding, no problem. But your neighbor cannot afford 4 hours now because it's going to affect his production. So what we then do is put a collaborative group together and say, okay, when there's load shedding or you have to reduce the load, Louis is not going to share, but somebody else is going to share. So we actually make time where it's most appropriate for the different people. We at the University of the Free State hasn't had load shedding for 2 years now. 2 years. One of my colleagues came to my course on Certified Energy Manager. He passed the exam, and to pass those exams is 70%, not 50%. This is 70%. If you have 69%, you fail, unfortunately. He came back to the University of the Free State. He said, okay, let's do load curtailment. In other words, before we go over the maximum, we actually curtail. We stop a couple of things. We switch off certain of the heaters. We switch off certain of the refrigeration systems for a period of time where nobody will actually realize it. And we have an agreement. So we're not going over our maximum demand, which means we haven't had load shedding for 2 years. Those are the type of things that everything that I've shared with you is 100% applicable to farms. Can I just add one more thing? I don't know if our readers are aware that there are two new laws in South Africa. The one says energy performance certificates. And energy performance certificate says it's a benchmark, an overall benchmark that says how many kilowatt hours did you use per square meter per year. And the law says by the 7th of December 2025, this is now extended by 2 years. Previously, every building that's larger than 1,000 square meters in South Africa, in the category education, in the category offices and sport, must have that on the outside of their building. And if you don't have that, 5 million in penalties and 5 years in jail. So every building has to be done. At the moment, agricultural buildings are not yet there. But the issue is not, does the law require it? The issue is, how much energy does a farmer use per kilogram of maize? How much energy does a farmer use per kilogram of cheese? If we have those benchmarks, we can say, is there MIDA, is there waste or not? The second one is that the law on electric lights has changed a month ago. All lights that are less than 95 lumens per watt. Lumens is the efficacy what comes out of the light. So I convert electricity into lumens. If it's less than 95, it's illegal to have it in South Africa to sell it. The people has got 1 year to get it off their shelves. 1 year from now on, it goes to 110, which means most of the fluorescent lights, all the compact fluorescent light, everything like that from now on is illegal in South Africa. Those are the things that agricultural engineers can take to agriculture, because the light doesn't know, I'm in a factory making cars, or in a factory sorting pomelos. Those are the things that agriculture engineers are not aware of, and we need to train them.
I agree with you there, Louis. So as we wrap up this insightful conversation, tell me, what are the future prospects for energy in agriculture, and what value can agricultural engineers add?
In my mind, and I'm absolutely certain about that, agricultural engineers are perfectly equipped to synthesize all the different aspects that is in a value chain. And I'm talking here about the value chain on a farm, on a farming enterprise, talking about both the engineering value chain as well as the biological one, to understand how the engineering will impact the fruit or how it will impact the microorganism in the ground. So the first one is they are really the only engineers that can synthesize that. Then agriculture engineers has got a unique ability to optimize, because agriculture engineers are taught how to approach a problem using the systems approach, how to get solutions. And the systems approach says, I want to understand how the one system interrelates with another system, but I want to know in that value chain system, what are we call it, the unintended consequences in the future. If I save now a little bit, I do not prepare the soil very well, and I think I'm saving fuel on my tractor, my plants are not going to grow optimally. If I plant in a soil that's not suitable, I don't have the control systems with smart farming systems, I'm going to plant and I'm going to also put fertilizer in for, let's say, for instance, a yield of 20 tons per hectare, but that soil can only give me 5 tons. So you are wasting. And then lastly is that agriculture engineers are well equipped for the fundamentals to quantify what's going to happen, to do the calculation, but they are not well equipped how to apply it. An agriculture engineer that comes from a university or a higher institute of learning will tell me, Louis, the theory says you can save 27% of your energy. The practice, however, says I need to understand what is the difference between the optimum point of efficiency for the pump, what's going to happen, and it's going to go down. There, we've got theoretical knowledge, but not the practical knowledge. So to summarize, the way that agriculture engineers are trained at the moment is absolutely wonderful, and their width of range of training is excellent. But how to apply it in real life, that's where the opportunity lies.
Besides the continuous education that you emphasized on throughout our conversation, what advice can you give to engineers who are interested in pursuing a career in energy?
I would like to repeat what you've said. Learning. Learning, it's lifelong learning. That is the crucial thing. And somebody else has gone through the process of collating lots of information that's available on internet free of charge into a specific course. So let me not go and redevelop the wheel. Let me go to the course and obtain that in the shortest possible time. So learning, and then with learning, it is the philosophical approach of the best investment you can make is to invest in yourself. So in short, continuous learning. That's the advice.
You've heard it, everyone. Continuous learning is the way to go. So, Louis, how can people reach you if they have any questions about your work or they want to inquire about the new BSc degree that the UFS is starting in 2025?
The easiest way, if we go to the website of the University of the Free State, under the website, there is a faculty, Natural and Agricultural Sciences. So that's important. Under the Faculty of Natural and Agricultural Sciences, under undergraduate studies, under Natural Sciences, they will find a specific section that says Engineering Sciences. So as long as they can get to the website, ufs.ac.za, Natural Sciences, Undergraduate Studies, Engineering Sciences. They can also contact us at engineering-sciences@ufs.ac.za. I'm going to repeat that, Engineering Sciences, one word, at ufs.ac, AC for academic, .za. And I'm going to give you a telephone number as well. The telephone number that they can call is 051, and the number itself is 401-3780. So the code is 051 and the number is 401-3780.
Thank you so much, Mr. Lagrange, for such an insightful discussion that we've just had today. I've learned quite a lot from this, and I believe it's the same for our listeners. I believe they've gained positive insights into the energy sector and what agricultural engineers are doing there. And any last thoughts?
Last words to everybody. Never stop your natural curiosity to ask, how does this work? Never stop your natural curiosity to ask, can we do it better? If that natural curiosity is not there, nothing else will work. So be a natural curious person. Then you are going to have success. Doesn't matter whether it's engineering or anything else, you're going to have success and you're going to make a difference to the South African economy. Thank you for the opportunity. It was lovely talking to you. And we can follow up with other discussions should you have the need in the future, specifically about energy and electrical energy. Have a great day, everybody. Thank you. Goodbye. Thanks, everybody.
Well, that was it from Mr. Louis Lagrange, who gave us a deep dive into energy in agriculture. Thank you for tuning in and listening to the Agricultural Engineering Podcast. We appreciate your support. Don't forget to like, rate us, and comment. Share this podcast with your friends, family, and colleagues. You can find more information in the description box, and we look forward to connecting with you in the next episode. It is goodbye for now. Thank you.